The odometer test provides valuable information about the soil's behavior under load. It helps engineers understand how much a structure will settle over time and how the soil will compress under applied loads. By conducting this test, engineers can make informed decisions about the design and construction of structures on the soil. To carry out an odometer test, the first step is to prepare the soil sample. This involves obtaining an undisturbed soil sample from the field using a suitable sampling method. The sample should be trimmed to the desired size and shape for the test. It is important to ensure that the sample has a flat and parallel top and bottom surface. The initial dimensions and weight of the soil sample should be measured and recorded. Once the sample is prepared, it is placed in the odometer apparatus. The apparatus consists of a loading frame, a loading plate, and a porous stone. The soil sample is placed on the loading plate, and the porous stone is placed on top of the sample. The loading frame is then assembled and the sample is subjected to a vertical load. During the test, the vertical load is gradually increased in increments. At each increment, the load is applied and held constant for a specified period of time. This allows the soil to settle and reach a state of equilibrium. The settlement of the soil sample is measured using a dial gauge or a displacement transducer. The test continues until the desired load increment or settlement criteria are met. The data collected during the test is used to plot a graph of load versus settlement. This graph is known as an odometer curve and provides valuable information about the soil's compressibility and settlement characteristics. In conclusion, the odometer test is a laboratory test conducted on soil samples to determine their compressibility and settlement characteristics. It is an important test in geotechnical engineering for predicting the settlement of structures and assessing the time-dependent behavior of soils. By following the general procedures outlined in this script, engineers can obtain valuable data to inform their design and construction decisions. Saturate the soil sample with water to ensure that all voids are filled with water. Place the sample in a permeable stone or membrane and saturate it by allowing water to flow through the sample for an adequate duration. Set up the odometer cell with a porous stone or membrane at the base. Place the saturated soil sample in the odometer cell and ensure proper seating and contact with the porous stone or membrane. Attach the loading cap to the top of the soil sample. Measure the initial height, h0, of the soil sample. Apply a small initial load to the soil sample to ensure proper contact and minimize air voids. Gradually apply loads to the soil sample in equal increments. Allow sufficient time for the soil to undergo consolidation at each load increment. Measure the corresponding settlements, DH, at regular time intervals until the settlement rate decreases significantly. Record the applied load, corresponding settlement, and time at each reading. After reaching the maximum load, gradually unload the soil sample while continuing to measure settlements. Plot the settlement versus log of time curves for each load increment. Determine the coefficient of consolidation, CV, and the compression index, CC, from the settlement data. Prepare a comprehensive report including details of the test procedure, equipment used, soil properties, and the obtained results. It's crucial to follow standardized testing procedures and safety guidelines while conducting odometer tests in the laboratory. Always refer to relevant standards such as BS 1377, Part 5 or equivalent for detailed instructions and specifications.